Okay, this is both smart and simple device. It's load matching modulation. The unit varies its burn rate in relationship to load, which has two sensors, high and low, on the tank in order to tell it what flame it should be working at. It has a burner delay, which is basically it looks at the load requirements and say, gee, do I really need to turn on or don't I? And very often the answer is you don't. It's the charm of having a high mass system. It takes a lot of the guesswork out of the hydronic system. It has a standard outdoor reset that comes with the unit. You have just a couple, 3 different parameters you put into the system, and then the tank actually adjusts according to outdoor temperature. So as it gets colder outside, the tank temperature will go up. I should note here that there's about a 20-degree difference between the temperature in the tank and what will be delivered out to the, call it, radiant floor heating system, because of the differential that you experience in going across the heat exchanger. That is the plate heat exchanger inside the module. So this unit can actually go up to 160 degree supply water temperature out to the system if you want to set the unit as high as 180 degrees in the most extreme conditions out there. Typically that would be saying you're using some sort of radiator or higher temperature product. More typically, let's say 140 degrees and down, the maximum temperature might go to 160 degrees in the tank. But again, the outdoor reset takes care of that. You just have to put in the parameters of how low do you want to go, which would be not lower than your domestic hot water temperature you want, and how high you want to go, and then just the reset curve, and we'll just do it automatically. It does have an electronic priority domestic hot water, so it actually senses through BID logic when the temperature is falling in the tank at a curve that's consistent with the domestic hot water load, and it will deactivate the pump going to the space heating while that curve exists, and it will automatically go back when the domestic hot water has been satisfied. And it does this actually in a not just an on-off type condition. It's going to look at the profile of the curve in order to give the maximum performance. This has detailed fault information. You'll find that all your fault information is in English. It's much more expansive. It's and detailed relating to what the system is doing. You can see all the different temperature probes, including going to and from space heating, to see what's going on in the system. It also has a service schedule management. If you wish, you can put in parameters either by run hours or by date to have a notice pop up on the screen suggesting that it's time for service on the unit. The notice, I was just pointing out that this system control is controlling these 2 pumps in an intelligent manner that we normally would have seen with a lot more piping and complications. I'm going to take a quick break here to look at some questions. Okay, I had a question about delta T across the flat plate heat exchanger. I think I got to that one. That's 20 degrees delta T. Is it okay to run PRV off the tank and the heat exchanger module? Yes, you can combine them by code. What is outside shell made of? If I understand the question, the actual outside shell is a PVC and vinyl type of material, and with foam around that. The 316 stainless is, and we'll get into that more, is actually the tank, and you'll see 800H and copper nickel in the combustion chamber. And I think you're probably talking about the outside shell in terms of that they have gone through, in terms of the plastic on the outside, they've gone through a very significant process of changing the formulation and the plastic surface on the unit to radically, they believe, will radically lower any problems with cracking in that shell that was experienced back with the Phoenix. Just a little bit of what we have, and I'll peek at what you'll see in the future. This is the box inside of the Phoenix. For those who are technicians, you'll really appreciate the way the Phoenix laid out very simply, and all the controls are on a big plastic board that can just pull out, so you have very easy access to get at all of this. And there are no more plastic clips that can break off for the boards coming if you ever want to take them off. But if you start over here on the left, we just have power coming in. We have the standard pump on the system. And we have here is for when it says NA, that's for the future, is where the solar pump will be in the future, meaning that Phoenix Evolution Solar, next year you'll have a module for the solar built into it, and it'll all be fully controlled by this one control. Lower side here is the T-stat, either directly a thermostat or more likely off a switching control, so whatever your switching control strategy is, pumps or not. This is actually for the future, NA, where you'll actually plug in the pump going out to the system, and that will then variably control, rather than having a separate variable speed circulator. They'll actually be able to control that variable speed circulator on a variable basis right out of the control. Outdoor sensor hooks up neatly here. Over here will be in the future where your solar sensors are and your solar pump. So it's a very straightforward kind of layout on this and very easily accessible. These are just quick snapshots, but every way we put it, when you put a quality condensing low mass device with an indirect water heater and the primary secondary piping that needs to go between the two and the circulator going to the indirect water heater, you're going to have significant savings. And it's very hard when we've also studied a variety and gotten data from a variety of contractors that between the actual component parts and the savings in installation between this and an indirect and a boiler, we're talking about a couple $1,000s, cost. I know it's hard for us all to conceive of that, and you think, oh, gee, a Phoenix or a Phoenix Evolution is expensive, and the question is, compared to what? Now, I wanted to just discuss, this is John Siegenthaler, who I think a lot of you are familiar with, and is sort of the guru of the engineering and hydronic business. He writes a lot for Plumbing and Mechanical and many other publications about this. He's had two articles, actually one in April and one in July, where he independently came up with what he saw as the dream machine. If only somebody would make something like this. Now, he didn't know that the Evolution was in the making at that time. So actually what he did, particularly in April article, is he came up with a design in April, almost exactly like what the Evolution is. And then he came up with further designs which are variations on those themes. Why? Because he wanted to meet certain criteria. Now, the high combustion efficiency is without a question. We've had independent testing by PG&E, which shows us substantially more efficient than our competition, condensing water heaters. Low head loss. Now, let's face it, when you have a water tube type low mass boiler, you have the pressure drop of going through that heat exchanger plus through an indirect water heater is substantial pressure drop. And in this case, we're lowering